Hello, I am Munjo Lee, the Director of the Education and Research Center at Omni CNS. From this fifth lecture to the seventh, we will be looking into the OmniFit Cognitive Function Check. In the fifth lecture, we'll cover data quality and the CMS report. In the sixth, we'll go over the detailed report. And in the seventh, we'll discuss whether the measurements were taken properly and how to handle certain situations. We'll proceed in order by comparing these different cases. First, in this fifth lecture, we'll look at the quality of the cognitive function check data, the relevant indicators, and how to interpret the CMS results after analysis. For the cognitive function check, you need to request data analysis after the measurement so that the analysis center can process and analyze the data. Therefore, after measurement, it's important to check the quality of the data and request analysis only for high-quality data. Collecting high-quality data allows us to more accurately assess the condition of the subject. That's why high-quality data is extremely important. This is especially true when it comes to biosignals. All right, then, shall we embark on an exciting journey into biosignals together? Now, this is the cognitive function check history. After we take a measurement, a screen like the one you see here will appear. At that point, it's best to first decide whether you want to request an analysis from the analysis center for the measurement data of that particular subject. As you can see, after you take a measurement, this is the guest for each section. In this person's case, you can see options for Request Analysis and Do Not Analyze. So, before you click on Request Analysis, if you click on the magnifying glass icon here, you'll be able to see the signals from your measurement results. As you can see, it displays Entire Section and Detailed Section. As you saw, in the upper right corner, it says Measurement Data. So, you need to check whether this person's data is properly recorded for each section. After doing that, you should decide whether or not you want to request an analysis of this data. As you can see at the very top, it says LEEG, which refers to the left brain. Left brain EEG, that's left EEG, and then right EEG, which is the right brainwave. So, the brainwave signals for each side are provided here as data measured over 5 minutes. Next, you have PPG, SDPTG, pulse, PPI, and packet. Each of these indicators is provided as well. As you all probably know, you're familiar with what EEG is, right? Let me briefly explain the indicator values shown here before we move on. What should we be looking at? You can do it. So, EEG values are indicators that come from the brain's electrical activity. And as I mentioned before, you can look at these according to each frequency band. Since this isn't the results sheet, you'll see information about these frequencies on the results sheet. But here, what we're checking is whether the raw data is good and whether the measurement data is clean. So, EEG refers to the brain waves from the left and right hemispheres, and then you have PPG as well. Yes, let's call it photography. Yes, this refers to volumetric brain waves. You remember, when we did the measurement, there was something clipped onto your earlobe. PPG can be measured from various places like the earlobe, finger, or wrist, but we're measuring it from the earlobe. So, by measuring the amount of blood flowing through the earlobe, we can observe this value based on how much light is absorbed when we shine light on it. When you do this, you must make sure that the PPG signal is coming in properly. The SDPPG value is derived from this PPG signal, and the SDPPG value is the second derivative of the PPG signal, similar to a brainwave value. So, when we look at the detailed data and also check the signal, it will produce a graph like this. As a result, the shape of this graph is very condensed and tightly packed in a short span. But it's very important to check whether the data is being provided consistently and coming out correctly. However, as you go along, you can see there's something odd near the end. Yes, you'll be able to see these kinds of areas again in the detailed data. Next, you can see that the pulse is shown at the bottom. This pulse represents the vibrations in the brain that are felt when the heart beats and pumps out blood. So, we record the number of these beats per minute. But we need to check whether these pulse values are coming in consistently and correctly. Only if they come in properly can we use those values for our analysis. And finally, a packet refers to the unit of signal transmission and reception in digital communication. If these packets aren't transmitted properly, the data won't come through correctly. If the transmission fails, it will also be difficult to analyze the data. Yes, we look at these kinds of indicators. So first, you look at the entire section, and then you might notice, something seems off in the latter part. To check if everything is accurate, you need to take another look at the detailed section. All right, shall we move to the detailed section and take a look? Yes, that's right. This is the data we measured earlier. Looking at the detailed section, you can see that, yes, the signal is coming in steadily and clearly. Next are the PPG and SDPTG. Yes, that's right. These consistent signals are being sent and received properly. Similarly, the SDPTG values are also showing a clear waveform on the graph. The pulse and BPI are coming in well without any packet loss. At this point, you can just click on Request Analysis. But now, shall we take a look at some data that wasn't measured accurately? Yes, that's right. This is an example where, just like what you saw earlier, the signals are coming in accurately and correctly. But here, there's a slight, Here too, it's slight, but when you look at the detailed section, these kinds of parts are where we can suspect arrhythmia. But if this pattern keeps repeating, then of course, you would need to remeasure and check the data in detail again. However, if it appears like this only at the end in some parts, there's a very high chance it could be arrhythmia. Now, for this person, the detailed section is, yes, a very well-measured example case. If you take a look, that's how it is. So, as you can see, it's recorded well like this. In this case, yes, good, right. Yes. You can just click on Request Analysis. However, as you can see, this kind of data is marked as an incorrect case. You should not request measurement analysis for this kind of data. In this situation, it's best to remeasure. Now, looking at this EEG, what do you think? Yes, here as well, and throughout the entire section, there's a lot of noise mixed in. In cases like this, it's often because the person moved their body or blinked their eyes. The same goes for the pulse as well. Because of that, the PPI value isn't coming in accurately either. Yes, shall we take a look at the detailed section? Yes. Looking at the details, it seems like in this part, they rolled their eyes around quite a bit. And in this spot, you can see them blinking their eyes. And over here as well, you can see a bit of pulse PPI, yes, in the atrium. This kind of difference can happen because of the intervals between heartbeats. But in this person's case, the most important thing is that the EEG signal has too much noise. So, you should definitely measure it again and then request an analysis. Also, when you get a result like this after measuring, you can just click Do Not Request Analysis or Do Not Analyze. Yes. Shall we take a look at both a good example and a bad example overall? What do you think? Can you all see it clearly at a glance now? Yeah, that's right. The one on the left is neat and well done. Even just looking at it with the naked eye, you can see that it's consistent and regular, right? But on the right, you can see that there's a lot of noise and it's all over the place. It's the same when we look at the two examples in detail. Yes, when there's a lot of noise like this, you shouldn't request an analysis. That's right. You should either remeasure or click Do Not Analyze. The reason we check the quality of the data like this is, as I mentioned, when accurate data is collected, we can analyze the subject precisely and understand their condition. Now, this is one of the good examples I showed you earlier. When we measure properly, yes, the ECG signal comes in clearly. Yes, looking at this spot related to HRV, you can see a bit of an arrhythmia pattern. So, in this case, we did a remeasurement. This happened around the 50-second mark during the first measurement. But since it seemed like there was an arrhythmia, we tried measuring again. And just like before, it didn't show up in the beginning, but in the later part, at 280 seconds, and again between 290 and 295 seconds, we could see arrhythmia again. There's another one here too. At around the 285-second mark. So, with HRV, it's actually hard to detect these kinds of arrhythmias when we're measuring for a short period of time. However, when you do a 5-minute measurement, you can sometimes find arrhythmias that you wouldn't notice in your daily life, and in these cases, yes, we can detect and check for them like this. In situations like this, that's right. Rather than saying it's definitely arrhythmia, we don't make a diagnosis like a hospital would. But since we see these findings, since this kind of pattern appears, that's right. So, it's necessary to let people know that they should go to the hospital for a thorough examination in cases like this. For example, during a demo for the mayor at a city market, when we measured his HRV, this kind of arrhythmia pattern showed up. So, we told the mayor right away, "It looks like you have arrhythmia." He said, "No way, let me try measuring it again," but the arrhythmia pattern showed up again. So we recommended that he go to the hospital for a thorough examination, and it turned out he actually did have arrhythmia when he got checked at the hospital. So, one of the biggest advantages of OmniFit is that it can analyze our biorhythms, things we might not even notice in our daily lives, using such accurate data. We took a look at the measurement data. Yes, after checking whether that data was accurate or not, we clicked on Request Analysis in the CMS. After that, the analysis results are provided. At that point, we can view the analysis results like this through the CMS. We can view the analysis results like this. Yes, on the CMS, we can now look at the comprehensive indicators like this. First, we see the Brain Function Aging Index. As for the Brain Function Aging Index, we said that the frequency that predominantly and dominantly appears in a healthy state in humans is called the intrinsic rhythm, right? That intrinsic rhythm appears most prominently in the range between about 9 and 10 Hz. However, we can analyze the aging of brain function by looking at changes in frequency caused by things like brain function decline, decreased consciousness, and increased brain fatigue. This is the CMS results sheet from Ms. Kim Chanaim that we looked at earlier. In her case, she's in a healthy state. Very good, actually. If you look at the back, you can see those intrinsic rhythm peaks. Next, we have the brain function instability. Alright, so the brain waves we measure are like this. With your eyes closed and in a comfortable, relaxed state, where there are no external stimuli like light or sound coming in, we measure the brain's default state, that is, the brain in its basic, resting condition. However, when you're tense, a bit anxious, obsessive, or under a lot of stress, no single dominant brainwave frequency appears. Instead, you see sudden spikes across various frequency ranges, like popping up here and there, showing this kind of pattern. In these cases, it indicates a very high level of brain function instability. Also, when the brain loses synchronization due to aging, the frequencies can become unstable like this. So, you can observe both emotional aspects and the degree of brain aging at the same time. Next, you can also look at the state of stress together. Acute stress refers to the analysis of temporary and short-term stress responses. Of course, when we're learning or going through necessary stages, we need to focus and the brain has to be active while experiencing some stress. But, that's right. As I mentioned earlier, the brain waves we measure are usually observed when the brain is in a baseline state, not engaged in any particular task, in other words, when it's relaxed. Therefore, when you're under excessive or intense stress, or in a state of heightened alertness or warning, yes, it's absolutely necessary to relax through adequate rest and sleep. Next, we can also take a look at chronic stress. When we are exposed to long-term stress or when such stress accumulates over a long period, the risk of developing metabolic-related diseases increases. Similarly, in these cases, if you reach the warning or accumulation stage, it's important to recover by practicing deep breathing, relaxation, meditation, exercise, and similar activities. So yes, in this person's case, their overall condition is quite good. Even though they are older, we are reviewing their data together, which is very standard. Next is the risk of heart disease. Again, we examine all these indicators through HRV. We analyze heart health using heart rate variability, which is the variation in intervals between heartbeats. Heart health is also, very important in our daily lives. If you reach a warning or caution state, it's necessary to restore your heart health through regular routines or consistent exercise. Yes. In other words, the person we are looking at is in good condition. Yes, next is the autonomic nervous system balance chart. The autonomic nervous system maintains its balance through the antagonistic actions of the sympathetic and parasympathetic nerves, which try to keep each other in check. However, when we are in a state of arousal, tension, anxiety, restlessness, or under severe stress, the sympathetic nervous system tends to become more active. On the other hand, in cases of excessive comfort or lethargy, the parasympathetic nervous system tends to become more active. But unlike brain waves, the autonomic nervous system reflects real-life situations very quickly. It can also be affected by deep breathing like this. So, when measuring, that's something you must keep in mind. It's best to take measurements while you're in a comfortable, relaxed state, with your eyes closed, and without doing abdominal breathing. Therefore, when it comes to the autonomic nervous system, rather than fixing your state based on a single measurement, it's very important to measure once or twice and observe the overall pattern. In this person's case as well, it appears that they are in a very healthy, balanced state. Next, if we look at autonomic nervous system aging, when someone is exposed to chronic diseases or long-term stress, the overall activity level of the autonomic nervous system decreases. So, when you reach a warning level, even light exercise, like I mentioned earlier. Yes, it's also very important to practice relaxation training through breathing exercises, such as deep breathing or abdominal breathing. So, in this person's case, yes, they are in a healthy state. Yes. Next, let's take a look at the last comprehensive indicator, which is the risk of arrhythmia. Earlier, when we were looking at the quality data, I mentioned arrhythmia, right? Arrhythmia is also very important. When we do health checkups or something, it's hard to check for arrhythmia in a very short period of time. Actually, yes. The risk of arrhythmia refers to a condition where the heartbeat becomes abnormally fast, slow, or irregular. So, as you saw earlier, how was it? It showed this kind of jagged pattern, right? Yes. So, normally, the heartbeat should be steady like this. Of course, there are slight time differences, but the heartbeat should be regular like this. However, if it's not, it's kind of like the clattering sound a train makes, like chickaduck or kook kook. Am I making the sound right? If you actually put your ear to the chest of someone with arrhythmia, you can hear those kinds of sounds. So, we've looked at the overall indicators, including arrhythmia. In the case of the test subject, yes, they are in a very healthy state. If this arrhythmia value occurs more than about 6 times within 5 minutes, you should go to the hospital and consult with a specialist doctor. Managing arrhythmia is also very important. All right, next, let's take a look at IEG and HRV. Yes, that's right, it's easy. It's brainwaves. In terms of brainwaves, in our CMS, we mainly focus on the power spectrum. I'll explain these indicators in more detail in the next detailed results section, and I'll also go over the characteristics of the frequencies again. If you look here first, yes, the one on the left is the left brain, and the one on the right is the right brain. Yes, in the power spectrum, the purple represents theta power, and the blue is alpha and low beta. Yes, the yellowish color is, that's right. Mid beta is orange, and then there's high beta and gamma waves. It's the same on the right side as well. In this case, for this person, you can see that the results are very ideally and clearly displayed. At this point, in this area, the alpha power, which is considered the dominant frequency in normal adults, or the dominant frequency for the person's age group, we analyzed the degree of brain aging based on the highest peaks in these values. The peak frequency of this level of brain function varies depending on age. For example, in 8-year-old children, it appears at a very low position, around 8 Hz, and it's the same for people in their 80s. For those who take good care of themselves, the peak can also appear at 9 Hz, but even if it drops down to 8 or 8.5 Hz, this peak in the intrinsic rhythm is still considered completely normal. The indicators given below, MEF stands for mean easy frequency, which refers to the average value of the frequencies we're looking at, specifically between 4 and 13 Hz. So, as I mentioned, since the dominant frequency varies depending on age, and especially since we're focusing on older adults, we're examining the dominant frequency within the range of 5 to 13 Hz. It's very important to note that we didn't just come up with these analysis metrics on our own at Omni. Everything is based on references. We're reviewing all these metrics through references and clinical studies. Secondly, PF, or peak frequency, is also very important. Yes, within the 5 to 13 Hz range, the peak frequency refers to the frequency at the highest point. So, in this person's case, you can see it clearly and neatly displayed here. Both the left and right hemispheres are symmetrical, and yes, it's presented very beautifully, or rather, impressively. I think this person's brain must be quite remarkable as well. Next is the ATR. ATR looks at the alpha set, the Ethiopia. This indicator is very closely related to concentration and relaxation states. When our cognitive function declines, we can't concentrate. So, when cognitive function is low, sometimes we can't fully focus on listening to what others are saying, and it's the same when handling work tasks. It's a bit difficult to immerse yourself and concentrate on just one thing. Yes, these are the indicators. We'll be able to see more detailed information about these indicators in our detailed results report. All right, next, you're curious, right? The position of this frequency. When we place the cursor, our mouse cursor, on the CMS, the corresponding frequency will appear like this. It's the same for other positions as well. So, you can check the value of the specific frequency in a more detailed and clear way. Not only does it show the frequency, but it also displays the power value together like this. I'm just marking the left brain. Yes, it's the same for the right hemisphere as well. In this person's case, both the left and right hemispheres are at exactly 9.6 Hz, which is very clear. This person is about 69 years old, and at this level, it's completely normal and indicates that their brain function is in very good condition. Now, you can see that the other frequencies are also represented smoothly and clearly. For people with a high level of brain function instability, you'll see other frequencies appearing in these areas in a very unstable, jagged way. Also, if you look at this alpha rhythm, you can see that the blue color is getting higher slightly to the left, meaning toward the lower frequencies, but that's inevitable as you get older. And in the case of young people who are still growing, the blue color tends to shift to the right, toward the higher frequencies. All right, next, let's take a look at HRV. Yes, HRV in real time is a very important indicator when we look at things like stress and physical health. Now, HRV also consists of the HRV index, TP, RMSSD, LF, HF, SDNN, and HR. It seems like there are a lot of things, right? But all of these, if you remember, we might have drawn them out once when we talked about stress. There's a graph called key QRST. When we look at HRV, it's this our point, and then the next our point that we focus on. In other words, all these values are actually calculated based on the intervals between the R points. In other words, it's also called mean RR. So as you can see here, this HRV index is, well, you can think of it as a comprehensive indicator of heart rate variability. That's why it's also a score that lets us assess the functional state of the autonomic nervous system. And TP stands for total power, which includes very low frequency, and high frequency, that is, sympathetic, parasympathetic, and also a very low value called VLF. It shows the total power value of those frequency domains. This also represents the overall activity of the autonomic nervous system. So, when this value is low, it indicates decreased energy, fatigue, or generally poor condition. Next, this is non-LF. NLF is also referred to as normalized low frequency. In other words, LF, which is the sympathetic nervous system, and HF, which is the high-frequency parasympathetic nervous system, among the total power of these, the low frequency, meaning the sympathetic nervous system, shows the proportion it occupies. So, it's one of the most important indicators for assessing the balance of the autonomic nervous system. Generally, we consider plus or minus 10 around 50, so 10 to the left and right, meaning 60 and 40. We usually regard this range as the normal category. If the value is too low or too high outside of this range, that's something we need to pay attention to. So, if it's above 60, it indicates that the sympathetic nervous system is overactive, which is usually associated with stress or a state of tension. If it's below 40, it means the parasympathetic nervous system is dominant. While this can indicate relaxation, if it's too pronounced, it may also suggest tendencies like lethargy or excessive fatigue. Next is LF. Right now, we're looking at analyses in the frequency domain. LF stands for low frequency, which mainly reflects the activity of the sympathetic nervous system. Here, we're looking at very slow rhythms, specifically in the range of 0.04 to 0.15 Hz. So, as I mentioned, excessive activation of the sympathetic nervous system can indicate hypersensitivity or strong stress, and it also happens when you're in a tense state. Even right now, as I'm teaching this class, I'm probably a bit nervous. That's why, for me too, the LF value is probably showing up a bit higher than the HF value right now. Next is HF. HF stands for high frequency power value. High frequency ranges from 0.15 to 0.4 Hz, which is higher than LF. So, it measures the absolute power value in the high frequency range. This reflects the level of activity of the parasympathetic nervous system. So, the parasympathetic nervous system mainly appears when storing energy, relaxing, or in a stable state. Yes. Next is the SDNN value. SDNN is one of the time domain analyses. It looks at the flexibility of the autonomic nervous system and its ability to respond to stress by measuring the standard deviation of heartbeats intervals. So, the higher the SDNN value, the more it indicates a healthy state. Next is HR. HR stands for heart rate. In other words, it's the number of heartbeats per minute, which is influenced by both the sympathetic and parasympathetic nervous systems. So generally, a normal range is about 60 to 100. This refers to the number of heartbeats per minute. The images you see above show the RR intervals, which are the intervals between heartbeats, and here, the tachogram displays them as dots. In this case, the heart was beating very slowly. For this person, specifically. Here, it's about 920 milliseconds, maybe almost 900 milliseconds. Yes, the intervals between the beats have been connected and drawn as a curve like this. And these have also been represented as a histogram. Our heartbeat can be a little slow or a little fast, but it's healthiest when it's not too regular and has a bit of rhythm. If the beats are too regular, the line would be almost straight. The histogram, too, ends up looking almost like a sharp utility pole, and this means your ability to cope with stress decreases. So, how was it for you all? Did you enjoy it? All right, with that, we've taken a look at the results of the cognitive function check on the CMS system. In the next session, we'll take some time to go over the detailed results together. Thank you all for your hard work. Thank you.